All right, so let's start talking about functions again. Remember, functions are things that pass the vertical line test when you graph them, right? So these guys are functions while these are not. Then I introduced some notation for a function. And I will say, if you ever go into a higher level math class like calculus, for example, this is the thing that like messes people up the most. And I don't really know why, because I've just been exposed to functions like for such a long time that I feel like it's so commonplace to me that it just makes sense in my brain. But I do know it does like cause the most issues in calculus. So that's why I want to stress a lot about this. That's why we're spending 2 days on just the notation of a function. Let's just say our function was y equals 3x minus x. If you graphed it, it would look like a function. And the way we would talk about it is to say that y is a function of x. And mathematicians, we don't like writing out really long term. So we'll usually say y of x, or even more commonplace is f of x. So you'll see instead of y, just f of x, g of x, h of x, things like that. This notation is really useful because if it really gives you the y value and the x value at the same time. Whatever is inside the parentheses is what you're plugging in for x. So f of x is just the regular function, but you can talk about f of b, where we replace x with b, f of k, where we replace x with k, or f of like 2, for example, where we just replace x with 2 and solve the equation or figure out what the value is that way. Okay, so we did a bunch of examples plugging in numbers into functions. Basically, whatever is inside the parentheses is what you plug in. And then we stepped it up a notch by not just plugging in numbers, but expressions. Like, for example, f of a plus b was replacing x with a plus b. Now, you have to be really careful when you do this. You have to put parentheses around what you plug in, or else you might make a mistake. We did a bunch of examples of plugging in expressions like h minus k and even negative x into our expressions. And that's kind of where we left off. So in this example, we have negative x squared plus 4. The first thing we did was compare what happens when we do negative g of x versus g of negative x. And you actually do get different answers when you do that, right? G of negative x is asking us to plug in negative x instead of x, while negative g of x is telling us to take the negative sign of the entire function. So there is a slight difference when we do that. The next thing we found was what g of a plus g of b was. And what that told us to do was to first plug in a, then plug in b, and then add together the functions. So that's kind of where we left off. Let's compare what we do here to g of a plus b. Okay, so now the plus sign is inside the parentheses instead of outside the parentheses. Let's see what this is asking us to do. Okay, if we're trying to find g of a plus b, what am I plugging in? A plus b, perfect. So wherever you see an x, you're going to write a plus b. Now, we have to be careful when we do an expression like this, because if you don't put parentheses, you might make a mistake. So I'm going to plug in a plus b instead of x, but I'm going to put it in parentheses so I'm not making a mistake. So this becomes minus, in parentheses, a plus b squared plus 4. So instead of x, I wrote a plus b in parentheses. Okay. What can I do to expand this first? Perfect. Separate the square into 2 a plus b's, right? Now, I can't do the minus sign yet because I have to square it first. Remember that thing called PEMDAS, right? And I can't put the 2 in here because, well, I have to expand it out first. So let's write a plus b twice, because that's what the square means, and leave everything else the same. Next, I guess I can FOIL, right? Or distribute, as some teachers like to say. I can take a and multiply it to everything, every combination of a and b, okay? What I'm gonna do here, oh yeah.
So when if you distribute before you attach the negative, does that mess up your answer at all?
Yeah, so I would say you can attach the negative, but the negative would only attach to one of these, and it'd be negative a plus negative b. I like distributing first because it just makes it easier when you attach the negative later on. You'll get confused with the negatives if you multiply it first. Yeah. All right. All right, let's just do the multiplication here. Let's do a times a, that is a squared, right? A times b is ab. B times a is ba, but another way to say ba is ab, right? And b times b is b squared. Okay, I'm gonna bring the minus down. What did I do wrong here? Gotta put parentheses, right? I just expanded out the a plus b's multiplied together. I need to apply that negative sign, and I didn't do that yet to the entire expression. So I need to put that entire thing in parentheses. Also bring down the 4, right? All right, are we good so far? All right, now what can I do? Make everything negative in the parentheses, right? So all of this is being attached with a negative sign. So I need to take that minus sign and bring it to every single term over here. So let's go ahead and do that. That becomes minus a squared minus ab minus ab minus b squared plus 4. Okay. Why is minus a squared and not just positive a squared? Yeah, because the negative sign isn't being squared, right? If it was negative a squared, then this would be positive, but we're just tacking on that negative up in front. What's the last thing I can do to simplify this? Perfect. Combine like terms, right? We have 2 negative ABs, so this would become a positive AB. So this actually becomes minus a squared minus 2ab minus b squared plus 4. And that would be a final answer because there's no like terms left to combine. Any questions on part C? All right. So doing g of a plus b is a lot harder than doing g of a and g of b and adding them together. The place where the plus sign is does matter here. Okay. Next one. This one looks a little funky, but I promise you it's not that bad. I want to find g of the square root of x plus 4. Oh gosh. What is this asking me to do? Now I have something in the parentheses, so I have to plug something in. What am I plugging into the function? Square root of x plus 4. Whenever we have something in the parentheses, it's telling me to plug in. That's what that notation's saying. So I'm going to switch my color here. Wherever I see x, I'm going to write the square root of x plus 4. Yeah.
The square and the exponent just cancel each other out.
Perfect. Now I'm not going to skip steps here because there is something that happens that you might make a mistake on, but that is correct. So let's go ahead and do this. So we have minus, right? The square root of x plus 4 in parentheses squared, and is it plus 4? I think that's right. Okay. Just like Dagan said, I am going to cancel out the square and the square root because they're inverse functions, right? Just like multiplication and division or addition and subtraction, square roots and squared cancel each other out. Now I'm going to write the next step and I'm going to do something slightly wrong. Okay. This is what's left. Negative x plus 4 plus 4. Why is that wrong? Put the parentheses, right? I cancel it out, the square and the square root, but I'm still taking the negative of that entire phrase. So I need to keep the parentheses there because if I don't, then that negative is not going on the 4. Okay, what can I do next to simplify this? Negative x minus 4, right? Just bring that minus sign to both the x and the 4. So this becomes negative x minus 4 plus 4. And what can I do to simplify this even more? Just negative x, right? Because the minus 4 and the plus 4 cancel each other out. Negative x is what I'm left with. All right. Any questions on how I got part C and part D? Yeah.
I thought you couldn't have a negative variable in the answer.
You actually can. So there's a lot of situations where the variable is just negative. That's totally fine. Yep. All right. If we flip over to the next page, I do want to leave you on your own for some of these, but I will say it has been a while since Monday, and I feel like we are just starting class. Let's go over part B together just because it involves 2 steps, and then I'll leave you on your own. I promise. Okay. Yeah, I got you. All right, let's do part B together. So the reason I want to do part B is it actually involves two steps that I haven't really talked about yet. So let's just say this. If, oh gosh, if t of x is 3x to the 7th plus x, I want to know what negative t of b is, okay? Now this is actually a two-step question because first of all, we have b on the inside of the parentheses, and also we have a minus sign in there. So I'm not just plugging something in, I'm also taking the negative, okay? So let's just focus on the t of b first and kind of forget about that negative sign, okay? What is t of b telling me to do? Plug in b for x. So all this is telling me to do is wherever I see an x, I'm going to write a b. So let's go ahead and do that. This will be 3b to the 7th plus b, okay? So I went ahead and did t of b, okay? What is the minus sign telling me to do?
Slap a minus on the end.
Yep, slap a minus on the end of the equation or at the beginning, right? Now, I'm not just slapping a minus at the beginning of the equation, I'm slapping a minus on the entire equation. So I have to put that entire thing in parentheses. So the b in green is just plugging in the b. The minus sign is just sticking a minus in front of it. So it's really two things going on at once. What can I do to simplify this even more? Yeah, bring the negative over to both the 3b to the 7th and the minus b. This becomes minus 3b to the 7th minus b. And that is a completed expanded version of my answer. All right. Any questions on part B? All right, I am going to leave you alone for parts A through E, okay? There actually is a part E on the back if you want to try that as well. But I'll be around to check to see if you're on the right track. All right, why don't we come back as a class here? I was gonna pick on people to write up their answers, but I do think maybe we should go through this a little bit more slowly, just so we're on the same page. I did want you to steam on it for a little bit, but let's just go through each of these. Okay, part A, what is M of 4 telling us to do? Ryan? Perfect. Plug in 4 to get 4 plus 2, and we get 6. So this is like the easiest type of question, right? It's literally telling you to plug in a number and figure out what it is. Okay, part C. We want to figure out what t of negative b is. So what is t of negative b? What is that telling us to do? Plug in negative b, right? So wherever we see an x, we're going to write negative b in parentheses, right? Because, well, it's a negative, and whenever there's negatives involved or like a big expression, we want to put parentheses around it. So this should become 3 negative b in parentheses to the 7th power plus negative b. I like to keep that in parentheses too, just because, well, whatever I plug in, I just keep in parentheses. Parentheses are never too bad to put around anything. Okay. So this actually isn't completely simplified because I can actually take this one more step. What is negative b to the 7th power? Negative b to the 7th power, right? And that's because the 7 here is odd, right? Now, if the question was this, negative b to the 4th power, would it be negative b to the 4th power? No, it'd be positive b to the 4th power because the 4 is even, right? So if the 7 is odd, then we keep the negative. If we have an even number like 4, then we take away the negative. So I can actually expand this out. This would be minus 3b to the 7th power. Now, plus and minus b is just minus b. Okay. Any questions on part C? Okay. Now, in this scenario, t of negative b and negative t of b, these actually ended up being the same answer. That isn't always true, okay? I think in the last example, we had an example where we did them and they were different expressions. It depends on kind of like the even or oddness of the function. You'll learn about that later if you go into calc or anything like that. But I will say sometimes they're different, sometimes they're the same. Okay. D, I think this one was the harder one. This time I want to find r of t minus 4. What is r of t minus 4 telling us to do? Perfect. Plug in t minus 4 anywhere you see a t. So since there's a t right here, I'm going to write t minus 4 in parentheses because, well, I have a big expression here and I think it might be easiest to do that. Okay. So I saw a lot of people doing this as I was walking around. Why can't, oh, wow, because I guess I like 14 better than 13. Good, nice job there. Why can't I bring the 3 and bring it over to the t and 4?
Square.
Yeah, because there's a square here, right? Remember, when you do like PEMDAS and stuff, you can't really do that. For example, if you were to do, I don't know, 2 times 5 squared, I can't multiply the 2 and 5 first. You have to square the 5 before you multiply by the 2, right? So here it's the same idea, okay? You have to apply the square first and then multiply by the 3. You can't multiply the 3 first. Okay. Now, personally, I like writing the t minus 4 twice. I know a lot of you can do this in your head. Personally, I just always make a mistake if I don't write t minus 4 twice. I don't know why. It just really messes with my brain. So I'm going to write it twice, okay? And now, actually, you can multiply the 3 over, but I think it's easier to FOIL first and then multiply by the 3. So let's just FOIL first and see what happens. Okay, so this becomes 3. I'm going to keep whatever I FOIL out in parentheses because I'm multiplying that by the 3. I haven't multiplied by the 3 yet, so if I keep it in parentheses, it keeps it all clumped together. What's t times t? T squared. What's t times negative 4? Negative 4t. What's negative 4 times t? Same thing. And what's negative 4 times negative 4? Positive 16. And I do have to remember to carry over that 13. All right. Now what can I do? Right? Yeah, I can do like terms. I think a lot of people multiplied 3 next, but let's combine like terms next. We have a negative 4t and a negative 4t. Let's combine those together. 3t squared minus 8t plus 16 plus 13. And now what we can do is multiply by the 3 to everything to get 3t squared minus 24t plus 16 times 3 is 48, right? Plus 13. Anything else I can do to simplify this? 48 plus 13 is 61. Perfect. 3t squared minus 24t plus 61. That would be my final answer. All right. Lots of steps going on there, but I think we were all on the same page as I was walking around. Any questions before we go to the last one? All right. Let's go to part E. Part E, we have f of x being 4x squared plus x. This time we have that pesky square root, which actually makes things easier a lot of the times. What is f of the square root of x cubed plus 4 asking us to do? Plug it in, right? That's literally what it's telling us to do. So wherever I see an x, I'm going to plug in the square root of x cubed plus 4 in parentheses because it's a large expression and parentheses definitely help us out. So 4 square root of x cubed plus 4 in parentheses squared plus square root of x cubed plus 4. I guess I'll put that in parentheses as well, just because I put everything in parentheses. Okay. What can I do to simplify this even more? Get rid of square root and the exponent. Perfect. And I'm left with 4 x cubed plus 4. What did I just forget? Parentheses, right? All right. Can I do anything with the square root of x cubed plus 4? No, right? I mean, there's no square and square root to cancel out. So I'm literally just stuck with this guy here.
So if it was x squared plus 4, would that still not?
No, you can't factor out x squared plus 4, but you can factor out x squared minus 4 with the difference of squares formula. Yeah.
So you can't do 4 times x3 plus 4x3.
No, because 4x cubed is multiplication. This is addition. Oh, did you mean doing this? Oh, okay, yes, you can do that. I thought you were talking about something different. But yes, Dagan has a good point. Let's take that 4 and multiply it by both of these, because that's something we can do. 4x cubed plus 16 plus the square root of x cubed plus 4. And that would be my final answer. You can't do anything with that weird square root, so we just kind of leave it alone. All right. Any questions on part E? All right. Let's keep going. So this is kind of the end of plugging stuff in with that function notation. We will talk about it a little bit more, especially a little bit later in this class. So I would say if you're feeling a little shaky on this, the quiz is on this, yeah.
So, last week, is this one? This one.
Last week's homework was not on this.
Oh,
Oh, oh, okay.
it's like what goes on, but-
I will say the homework that's due next Tuesday is on this. There's a lot of this on the homework for next Tuesday. I also, the quiz is gonna be on this, so make sure that you do it before Friday. And if you're still feeling a little shaky with all that practice, I do have 2 extra credit worksheets on this stuff. All right. Yeah, I don't think so. I think there's another one. Yeah. All right. Let's keep going. So, we're going to talk about domain and range. Domain and range can get very tricky, like very quickly. I will say in this class, we don't go too far into domain and range. I feel like there's other classes, especially Math 140, where we spend like a whole week on domain and range and it gets really crazy. I don't think we're going to get that far or that complicated in this class, but I do want to talk about it. I'm not personally a definition person, but I do have the definitions up here. Domain, you've probably heard of this. It's basically all of the X values that work for a function. So if you graph it, what X values have a picture, right? Are there any X values that don't have a picture of the function? Okay. The range is all the Y values that work for a function. So if you take a look at the picture, what Y values have a picture and what Y values don't have a picture, okay? So let's just take a look at this graph here. The first thing I want to talk about is just how to interpret this graph using function notation, of course. This is the graph of G. First of all, this graph looks really funky. This is an example of what's called a piecewise function. You might have heard of that before. And it's basically a bunch of different pieces, like kind of clunked together, essentially. Now, if you take a look at this graph, there's a lot of these closed circle dots, and then there's an open circle dot, okay? Basically, what this means is if you have a closed circle, it means that we're including that point. The graph exists at this point. If there's an open circle, it means that the graph does not exist at this point. So at 3, the graph, it looks like there's 2 points for x equals 3, but it actually, there's just 1 point for x equals 3, right? This graph doesn't exist up here. It exists down here, okay? All right, let's find g of 0. G of 0, okay? What this means is we want to know what the y value is when x is 0. Remember, anything in the parentheses is x, right? So let's just take a look at our graph. The x-axis is the horizontal axis, and when x is 0, it's over here. What is the y value when x is 0? 2, right? Because if I just look up, there's a point right here at x equals 0. G of 0 is 2. All right, let's talk about the weirdest part of the graph, g of 3. Now, if I want to find what g of 3 is, I need to find when x equals 3. Remember, the x-axis is the horizontal axis. So if I look on the horizontal axis at x equals 3, there's actually 2 points where the function is above or below 3. We have it up here and we have it down here, and I think I already hear it. -2 is our answer because that's where the closed circle is, right? So we're looking where the function actually exists. G of 3 is -2.
But if you were to say, if you were to use, basically that open dot means it's like 2.9999999 is still an answer up there.
Yeah, perfectly.
But once
So
it reaches that 3, it's not, it goes down.
that's a good point, right? So if I wanted to find what g of 2.9 was, even though like the open circle is at 3, you would still look up and see that g of 2.9 was 2, right? Yeah. All right. Now we are going to find the domain and range of this function. I know that there's space for you to write it on the next page, but I personally don't feel like flipping back and forth. So let's just find the domain here. Okay. Remember, the domain is all the x values that work for the function. So you're going to look at the x-axis and you're going to figure out, okay, where on the x-axis is there a picture and where is there not a picture? Now, just by looking at the x-axis, I can tell that there's no picture over here to the left of the graph, and there's no picture to the right of the graph, right? So my domain has to be where the graph is over here. And I have to think about all the x values that work. Now, can everyone agree Yeah. Can everyone agree that it's from -4 to 4? Okay, so let me just write this out. All the x values between -4 and 4. Okay. Am I including -4 and 4?
Yes.
Yes, because there's a closed circle, right? So let me write including. Now, this is a mouthful, right? Mathematicians hate writing out long things. We like symbols and numbers and all that stuff, but we don't like writing it out. So let me show you a way that you can write your answer. We call it interval notation, okay? And the way that I would write -4 to 4 is this. I would write -4, I'll put a comma and +4, and what that's saying is that everything between -4 and +4 works, okay? Now, we're actually going to put brackets around these. And the reason I'm using brackets is because we're including the point, okay? Now, you'll see later on in this class, I'll use parentheses. Parentheses is when we don't include the point, okay? But I'm going to use brackets here because we're including. So brackets mean include. Okay, well, we'll talk about parentheses later on in this class. But for now, brackets just mean we're including the point. Okay. Let's do the range. Okay, now the range is all the y values that work for the function. So as you look at the y-axis, as you look at it from up, oh my God, as you look at the graph up and down, you're going to think about, okay, where does the graph not exist up and down? So down here, the graph definitely doesn't exist. Up here, the graph definitely doesn't exist. So I'm definitely looking at the y values kind of like here, right? And those y values are -3 to +2. Does everyone agree with that? Okay. So let's say the values between
So I have to have
-3. Yeah.
for this, what was called the notation for the one with the bracket, what was that called?
Oh, I called it interval notation. Yeah.
And so when you go, I'm guessing it goes left to right.
hmm
Well, what about top to bottom or bottom to top?
That's where the range goes along.
Yeah, no,
So,
no, 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 I know, like how would you write the net, like the bottom number, like the lowest number first?
oh, yeah. So
Or the, like, where do you go from positive to negative or negative to positive?
we always write the more negative number first. So the lowest number always goes first, and the higher number goes second.
Gotcha.
Yep. Okay. Are we including -3 in my range?
Yes.
Yes. Are we including 2 in my range? Yes, right? Now, 2 is a little tricky because I know that there's an open circle at 2, but there's also a closed circle and also a line, right? So there's actually a lot of points where y = 2 on this graph. Just because there's an open circle once doesn't mean that we're not including it, okay? So we're including both of them. Yeah, if there was only one open circle, then we wouldn't include it.
So actually, I have a question. Let's say if somehow there was like that closed circle on the
Uh-huh.
y = 2 was open and there was like a parabola instead of a line, so nothing was on 2 beyond the open circle.
So it was like this.
Yes.
Yeah, then we wouldn't
Would
include
that
2.
mean, correct, so would that mean it would be bracket negative comma 2 parentheses? Like, would
We'll
you have
talk
one
about
bracket, one
that.
parentheses?
That gets a little more crazy. I will say we'll talk about that later, but what you would do is you would be like, okay, you would this is how it would look like. It would be, oh gosh,
Would it include-
-3 comma 2 parentheses
Okay, so I have-
and 2 comma what I
Okay,
yeah,
so you
okay.
got that.
Yeah.
Okay.
But that we're not going to deal with that yet.
Okay.
That's a little too
I was just-
complicated.
I was just trying to- I remember
Yes.
doing this in high school, so I was like.
I know. I feel like this is stuff that we have not seen for a while, but yes. Okay, let's do interval notation for the range, -3 comma 2. I'm going to put them both in brackets because we're including both. The only reason I'm really giving you this interval notation, this is what Alex uses. Okay, there's other notations that are used for domain and range. This is the one that Alex uses, and I think is more commonly used anyway. Okay,
I mean, kind of, it makes sense.
it does make sense. Yeah.
Like, what other ways are there to writing out?
There's this thing called set builder notation, which has like squigglies. interval notation, writing it out normally, Venn diagrams. Yes. Yeah, we're not doing that. All right.